Intermittent problems are probably the one thing that drive us crazy the most, trying to find them. One of the reasons they're so hard to find is we can't see them. Our limitations are human. Our eyes can only see so fast, we can only see so much, and our brain can only register so much. Sometimes that's where a lab scope comes in handy because it can see things faster than we can. It can look at more than one thing at a time. We're going to show you how to use the lab scope to try and find an intermittent problem. We've got a 2000 Pontiac Grand Prix 3.8 engine. The car came in and it's running pretty good, but it's got an intermittent problem. It's got a check engine light on. We had a code for engine coolant temperature too high. It surges now and then, and the transmission now and then will shift real hard. Since we had a code for an engine coolant temperature sensor, I'm going to choose that. I'm going to choose the coolant temperature sensor. Now I'm also going to go up here to open and close loop. Then I'm going to save that list. Now it's always going to show RPM, TPS, but it's also now going to show open loop and coolant temperature sensor. Now, what I want to do is look at both of these. I only have one screen displayed, so I'm going to go up here and pick two screens. Now it's going to show both, and I'm going to go down here and highlight open and coolant. So here's my open loop coolant temperature sensor. Now you can see the temperature is climbing up. We're up to 212 right now. I'm going to brake torque and put it in drive. You should be able to hear the engine brake torque. So now you can see by this, every time I accelerate the engine hard, the temperature drops down to minus 38, or we basically get an open circuit at the coolant temperature sensor. And one time it dropped down to open loop. So now we know we've got an intermittent condition. The signal's dropping out intermittently. Now the first thing we've got is a little wire harness here. Both ends are accessible. One goes to the coolant temperature sensor, the other one goes back to the harness. We're going to ohm this, so we're going to put a lead on both sides. You can see the multimeter there. We've got contact. Now we're going to actually wiggle these wires and see if anything drops out here. We're wiggling both sides. Nothing drops out. We repeat that for everyone in there. We found no problems with the wires. The next thing I like to do with intermittent problems is actually look for the pin connectors to make sure they're tight. Now I take my little pick and I try and insert it underneath the spring-loaded part and kind of tweak it. Make it expand so that the one that slides in there will actually touch on both sides. So at this point we're going to go plug this back in, redo our test, and see if we've made any improvement. Okay, we just dropped down. We can read over here at minus 38. Our minimum now is reading minus 38, maximum 219. So our signal dropped out. We're reading minus 38 degrees now. The only thing we've done is shifted into reverse. Okay, we've got some evidence now. When we shift it into reverse, the problem shows its face. Still not sure what it is. Now, if you know the scanner, when we're tapped into the scanner reading the PID data, we're reading what the scanner is seeing, or else it's substituted value, one or the other. So we're reading it from the scanner's point of view. We're not really reading the sensor. So this is one of those times where you can't believe what you're seeing. This is a running engine at normal operating temperature. It is not minus 38 degrees. So is that minus 38 degrees a lie? No, it's a substituted value. Remember, fuel delivery or injector pulse width is a calculated value. Since it's calculated, there must be values there to calculate, something to calculate. In an equation, each value must contain a real value or that calculation can't be completed. So when the computer sees no signal at all, it substitutes a value so that that calculation can be completed and the engine can continue to run. So why minus 38 degrees? Why not 0? Well, it's simple, really. An incorrect temperature sensor reading is not enough of a reason to shut the engine down completely, but it is enough of a reason to draw attention to it. So the PCM wants to keep the engine running, so it substitutes a value so that that injector pulse width calculation can be completed and the engine can continue to run. Well, you might think it would use a 0 instead of minus 38 since the signal dropped out completely. Well, remember here we're talking about a thermistor. It gets 5 volts and decreases as the temperature rises. 0 is still a value, and it can be calculated. So instead, it substitutes a value that is unreasonable, but will still calculate. This keeps the engine running, but it also triggers the check engine light. So remember, whenever you are reading your scanner and you see a value that is unbelievable, don't believe it. It might just be a substituted value. So I'm sitting here thinking, well, is it the signal? Is it the coolant temperature signal? Is it the wiring in between? Is it the computer? Are we losing power or ground, or what are we losing? So we're going to tap into the coolant temperature sensor circuit, both the power side and the ground side, and we're going to monitor that signal. So how we're doing that, we're going to use the 2-channel lab scope with 2 wires. We're going to look at 2 signals. Now we've actually opened up our wiring harness so that we can examine some of the wire, thinking maybe we have a frayed wire or something. The wires actually look okay. So we're tapping into the signal wire from the coolant sensor and the ground wire from the coolant temperature sensor. And I have my 2-channel lab scope. I'm reading the yellow and the green. The yellow is on the power wire. I'm reading 1.7 volts. The green is on the ground wire and 0.02 volts. So this is indicating a good ground. Now this is 1.7 volts. Just so that you remember, the coolant temperature sensor gets a 5-volt reference from the computer. As the temperature goes up, the voltage goes down. We're reading 200 and some degrees now, so that's why we're 1.7 volts. Now the yellow signal over here then is the voltage. The green is the ground. Now by setting it up this way, I can look at the lab scope live data, and I can just toggle back and forth to the scanner. Or I can go back to the scope. So I can go back and forth. I've got this set on a 30-second sweep. So it gives me 30 seconds to switch back and forth between the lab scope and the scanner. Now the reason I'm setting it up this way is because when I'm here at the wiring harness and I'm tapped into the wires at the coolant temperature sensor, I'm looking at the signal before it gets to the computer. I'm looking at it directly from the coolant temperature sensor, the circuit. I have not unplugged the coolant temperature sensor. It's still plugged in. The circuit is still intact. I'm just tapped into it. That's what I'm reading here on the lab scope. When I'm looking at the scanner, again, I'm looking at the scanner data. Okay, we've got it set up. We're looking at the scanner, and we're not seeing it drop out anymore right now. This problem has been really intermittent. Now, these are the really tough ones, trying to get it to fault when it won't do it on its own. But I'm thinking it has something to do with either brake torquing or shifting the transmission. The wiring is not connected in any way. We've actually looked at the wiring diagram in terms of the signal wires. So I'm thinking maybe it's at the wiring at the transmission. So I'm going to reach down here and jiggle the transmission. As soon as I reach my hand down there, I noticed that the signal dropped out. It's down to minus 38 degrees. And I didn't even touch the transmission. The transmission connector is down there. The only thing I did was reach down here, and you can see the signal drop out. Now it appears every time I touch this air breather duct, you can see our signal dropping out. So when I push on this, the signal drops out. But if you notice, when I'm pushing on this, I'm actually pushing on the breather box as well. Well, this is all attached, and in this car, the computer's actually in the breather box. So if I bang this, and you look at the lab scope, you can see that the signal's dropping out. You notice the more I wiggle this box, the more our signal is disturbed. If I stop it, it goes back and has the signal. Now I want to show you going back to the lab scope. Here's the signal. It's where it's dropping out. When I start wiggling this again, when I stop, it stops. Now if you notice, this is the power side, the voltage side, 82 volts. The ground never changed. So our problem is on the voltage wire, the power wire. Notice the ground never changes. The power does. Now it looks like in here, the computer's in the breather box, and when we disturb that, we disturb our signal. Same thing's happening when he's driving down the road and he shifts or hits rough roads or something like that, and it causes it to disturb the computer. So what we're going to do now is take the computer out and examine that and see what we can find as our problem. Take the breather out of the way and we can see the computer down in the air path to keep it cool. Okay, we'll get the computer out where we can work on it, see it a little bit better. Okay, we've got our computer disconnected, and you can see that there's two connectors on there. We went to our wiring diagram, and it shows us that the yellow wire is going into pin number 26. We looked at our numbers. Pin number 26 actually comes in right here, the yellow wire. So we turn that over, we're the sixth one down. We come over here and we look at the sixth, and it actually looks okay. There doesn't appear to be any disformity or any kind of big corrosion or anything in there. And we looked in the back, we found our two wires, actually the one wire, the yellow wire right here, and we wiggled that and we never got it to drop out again. But we did notice that whenever we would just rotate this thing, the signal would drop out. And we rotated all kinds of different ways and it was real inconsistent, but it would drop out. What we wanted to do was rule out a wiring problem before we condemn that computer, because it'd be real easy at this point just to say that computer's bad. But instead of doing that, what we did was actually ohm it. We set up our lab scope for ohms. We back probed right in here. And then we went back to the same wire that we were on when we were testing the signal there. So we tried to ohm right here between these 2 points, and we got a real erratic signal. In fact, most of the time we couldn't get any continuity at all between here. So then what we did, we actually went to the connector coming out of the coolant temperature sensor and disconnected that, going to the harness side, and we tried our continuity test between here, and we had good continuity. There was a very strong continuity between these 2 points. So then we went back here, back to this point, and still had no continuity. So we're suspecting it's got to be either in here or in the wiring. So we decided to peel the wiring back and try and go back and see if we could find a problem in here. And if you look right here, sure enough, we had a wiring break. This yellow wire is the wire we were trying to get continuity on. It's all exposed now, but in there it was just barely touching. So now when we do continuity between this point going back to here, we have good continuity. So this was our break all along. So now what we're going to do is splice these wires back together and see if our signal stays good at that point. We've got our wire fixed. We're back on our scanner. You can see we're reading 160 degrees and it's stair-stepping up as it gets warm. We're up to 174 right now. So I've got my computer. We've got our wire fixed. Shaking it around. Tapping it. Wiggling the wires. We continue to climb upward. Signal doesn't drop out. It confirms that that wire was the problem. So this was a little difficult to find. And believe me, there was plenty of opportunities along the way to just kind of say, well, that must be it, and throw a part at it. Even all the way down to the point of saying, well, it must be the computer. Let's throw a part at it. But you know, if you understand the system, you understand voltages and signal dropouts, and if you got all this sophisticated equipment, why not use it? Sometimes you just have to keep digging and digging. I actually was going through this and thinking, well, it's probably the computer. But rather than put a part in there and charge the customer for a probably, what we really wanted to do was rule out everything else. And when we were ruling out everything else, even though we were thinking it was probably a computer, we actually found the problem. Be persistent, and the evidence will lead you to the problem.